430 millimeters, so around 443 centimeters. Hi there, my name is Sergio, and I help companies, students, and freelancers to easily and efficiently apply visual recognition to their projects. We're going to see today a simple implementation of the Intel Realsense d435i camera. This is a depth camera that you can use to track not only the object but also the depth of the frame that you get, so you can get exactly the distance of each single object. And I used this in the past for some commercial project, and it's essential when you need to work with commercial projects, especially for manufacturing companies, where you need also to get not only the X and Y position of the objects, but also the Z position, so that the robot arm knows exactly where to go also on the Z axis, so that you don't smash the object if you go too far or if you are too high, especially when you have objects which have different sizes. But you can also use this one for different projects, for emotion recognition. When you have the depth, you get better accuracy. And also you can use this camera for three-dimensional objects, so you can get the objects in 3 dimensions because you have a clue of where is the distance of each part of that object. But for today's tutorial, we're going to keep things simple and we'll focus only on distance detection. We'll do this in 2 steps. On the first one, we are going to get the frames and the information from the camera, so we'll get the image in real time, also the information of how far are the objects. And in the second part, we're going to integrate this with Opencv so that we can show in real time using the mouse the position of each single pixel. I hope you're ready for this, and let's start. Now, before proceeding, you need to make sure that you have everything installed to use this camera. And we need 2 things. We need Opencv, which is the library that we use for computer vision. And second, we need Realsense 2, which is the module to run this camera. And I will go quick with the installation cmd, and then you can install them with the pip Python command. Pip install Opencv Python, that's one. Of course, I have a requirement already satisfied, and so I have it, and you need also to make sure that you have it. And then pip install the second one, Realsense 2. And the requirement is already satisfied in this case as well. And so if you want to be 100% sure that the installation is correct, we are going to import cv2, which is Opencv. Then we import Realsense 2. And if you run this one and you don't get any error, it means that the installation is done correctly. Now, to work with the camera, there are some functionalities and libraries released by Realsense. To make things more simple, I created a new file, which is this one, Realsense depth, and we will be using this one. So if you don't have this file, you need to download this file from the link below. It's called Realsense depth from the blog below. You will find all the instructions. And once you download this file, there are 2 files, Realsense depth, which will be the file that we will be importing on our project, and then detect distance is the main file that I am coding right now. So you need to import this one, and this one you will get as well, but that's what you will see right now that I am doing. And once you have this one, Realsense depth, we are going to import Realsense depth. But better, from Realsense depth, we're going to import everything. So from Realsense depth, we're going to import everything. And I made this file in a way that in just a few lines of code, we can extract all the information that we need from the camera, and it will be really easy even if you are a beginner. First of all, let's initialize the camera. So initialize camera. Of course, this will for the Intel Realsense. And it's simple. We can say DC, which stands for depth camera, equals depth camera. And this is this class is inside Realsense depth. Now from that camera we can easily import the BGR frame, so the color frame, also the depth frame, and in just one line, red, then depth frame, and also color frame equals dc.getFrame. To see and make sure that everything is working correctly, let's show this frame on the screen. cv2.imShow, and we're going to show the color frame, and then color frame. Now let's make a wait key event to keep the image open, cv2.waitKey 0. And now we can run this one. And this is the color frame that we are getting from the camera. And now let's also get some information from the depth frame. We made the depth frame also in order that from the original frame we can extract the distance of each object. I'm going to show you the depth frame even if it's not the way that we use it, but let's now show the depth frame. cv2.imShow depth frame. Now depth frame. The depth frame is a frame which has the same shape of the color frame, but instead of containing the image with colors, so the original frame from the camera, this arrays is containing for each pixel the distance of on the space from the camera to the object. And we're going to make this a simple example right now. We're going to take some specific point of the frame and show the distance for that specific point. Let's see that. Let's take, for example, show distance for a specific point. And we are going to take, I will take some random point, let's say position 400 and 300. Let's show also this point to have a clue of where we're taking the distance from. cv2. How do we show it? Of course, the best way here would be to draw a circle on this point so that we know where the point is on the frame. cv2.circle. We want to draw the circle where? We're going to draw the circle on color frame, and we will put the circle on the position point, so position 400, 300, and then let's make radius 4 so that we can see it well, and let's make this circle red. So 0 of blue, 0 of green, and the maximum of the red, which is 255. And now we can run this one. And as you see, we have here the circle which is getting the chair, this red circle right here. As we now have this circle, how do we know how far is from the camera this specific point? Well, in order to get this information, we need to refer to the depth frame. So on the depth frame, we need to go on the same position, which is this one, and from that position get the value of the point. And it's really simple. We have distance equals, we take the distance from where? We take the distance from depth frame, and then from that frame, where exactly? We have an exact position, so we define the indexes. We have 400 from the X and 300 from the Y. So 400 starting counting from the left side and 300 start counting from the top. And the only thing that you need to know that when we work with Opencv, when we work with more specifically with the arrays, instead of putting first the X position and then the Y position, we need to put first the Y position. So we will put point index 1, so we're taking first the position 300, and then point index 0. And let's show the distance, print distance. And let's wait that this initialize, and we see now a value which is 802. 802 is the distance in millimeters. This means that the camera, the depth camera, is around 80 centimeters far from the chair. So 800 millimeters or the same 80 centimeters. And I will make now this in real time so that we can try to play around with this. So we can do that by, instead of taking only one frame, we want to switch to real-time detection. So from after we initialize the depth camera, we also do while true, and we put everything inside the while loop. So the video in real time, it's nothing more than images one after another. So we're getting a frame after frame and do all the processing for each frame that we get. Just one last thing that we need to change is the cv2.waitKey0, because if now I run this one, even if there is a while loop, it doesn't move further unless I press a key. When I press the key, each time I press a key, we go to the next frame. And we don't want that. So we remove, instead of waitKey0, we use waitKey1. waitKey0 freezes the frame. waitKey1 waits 1 millisecond and moves to the next frame. And then we say also key equals waitKey1. So if the key is equals to 27, which is the S key on the keyboard, we can break the loop. So I'm doing this in order that if we want to quit, we can. Otherwise, there will be no way to quit normally from the window. And now let's run this one. As you see now, we do not only have the frame, but we have this in real time. And now let's play around with this one. When I go closer to the point, you see now we have around 305, so we have around 30 centimeters distance. And the farther I go, the more this number is increasing. Sometimes we have some errors, so it's not 100% precise. This will require some filtering, some more advanced method, which is not the case of this tutorial for the moment. But you need to know that this camera is quite precise and detects the distance from 10 centimeters to 2 meters with 2% margin error maximum. This means that if the distance, the object is around 1 meter, there can be an error on the depth detection of maximum 2 centimeters. If it's 2 meter distance, the error can be up to 4 centimeters, which is quite good detection, we can say. Now, we've done with the first part of this tutorial, which was getting the information from the camera. We have the color frame, we have the depth frame, also we have the position of one specific pixel. Now on this second part of this tutorial, we are going to focus on integrating Opencv with the mouse function. So we will have a function that when we move the mouse, we get the position of where the mouse is, and for that position we get the depth. For example, the idea will be that if I go, I put the mouse on my nose, it will tell the distance from the camera to my nose. If I put the mouse on the wall, we'll get the distance from the camera to the wall. Let's do that. The first thing that we have to do is creating a mouse event so that we get the position of the mouse when we move it inside the window. So let's do that. Create mouse event. To create a mouse event, we need first to create a window, cv2.named window, and this window needs to be the same where we're showing the frame. So if we create a window, then let's make sure that it has the same name of this color frame. So color frame. To this window, we're going to associate a mouse event, cv2.setMouseCallback, and now we need to pass two parameters. Set mouse callback where? Of course, on the color frame. So we're going to say that on this color frame, we want to activate the mouse functions. And each time the mouse is over the color frame window, we want to use this function, which we can call as you wish. Let's call this show distances. Or let's say show distance. And now let's create also this function. We will create this at the beginning, def show distance. And there are a few parameters we need to pass, and that's how it works with Opencv for mouse callback functions. We need to pass first event, x, y, args, and params. Don't worry about all these things. We will use almost none of them. From this, we will just use x and y. And we'll just print x and y. X and y, and let's now run this one. And I will show what this is doing right now. Once we run this, have a look right here on the printing. When I go with the mouse, not on any window, but on the window where we associated the mouse callback function, so you see color frame, when I go on that window, we see the printing as output the position where the mouse is. So if I go on the top, of course, we have around 0, 0 almost. So each time I move the mouse, I get the new position and we have that specific position. And using this, we can change our position of interest in real time. For example, there is this red circle that we have right here. By changing this position in real time, we could also move this red circle in real time. And we're going to do that so that later we can get the distance from this circle. And let's do that right now. So how do we do this? We need to find a way to take these coordinates, which are x and y, and put them inside point right here. Of course, we can't do just taking x and placing the x here. You will see this is an error because we cannot take the variables from a function and just take it outside of the function. But we can do something similar. We take point. We're going to put the point outside the loop because we don't need the point on the loop. And let's put the point just here at the beginning, point 400 and 300. The thing that we can do is changing this point in real time. So now if I run this one, it doesn't change much. Point was 400, 300 before. It's the same right now. So we see the circle always here. But we can do one thing, which is global. So we're assigning global to point. And then we can say point equals x and y. So each time that we, first of all, at the beginning we have point 400, 300. Let's see that. So as you see, we have the circle there. But when we move the mouse inside the window, you see now the red circle is where the mouse is. And having this now makes things really easy for us. From this point position, we can take the position from the depth frame, and then of course we get the exact position, the exact distance from that specific position where we have the mouse. Let me do this. We have distance. We have already distance, so let's show the distance on the screen in real time. cv2 dot cv2 dot put text. We're going to put the text where? We will put the text on color frame. And then what is the text? We want to show the distance. We will do it this way. Dot format and then distance. And now let's put mm for millimeters. And then what else? We need the position. Okay, I forgot. We need the position where to put the text on the screen. And we're going to put the text on point 0, the x position, and point 1 is the y position. We could also put just point right here, but I will explain why I did it this way later. Then font face cv2.font. I will just take the first which I see for hash play. We don't really care now about which font we are using as long as we see the information. Font scale 1. And then finally the color. Let's make the text black. So 0 of each color. 0 blue, 0 green, 0 red. And thickness of the text 2. And that's it. Let's run this one. Okay, we have 2000 mil. Okay, as you can see, probably the text is too small. So there is something to change. So let me quit this one and let's change something of the formatting of the text. So 1 is too small, so let's put font size 2. But also, if here we have the point, and we have the mouse, I want to put the text a bit more up from the point position. So that's why I extracted the x and y from point 1 so that I can add -20 so that we will put the position of the text a bit above the position of the point. And so it should be everything that we needed, and let's run and test this one right now. Okay, now we have the position of the text. This one you see 2400 millimeters, which is around 240 centimeters. If I go on my head, is around 430 millimeters, so around 443 centimeters. The chair is around 80 centimeters, and so on. The position is not always 100% exact. In some part we see 0, so there will be some function that we will need to implement, like some filtering, in order to avoid these errors where we see 0. Also, it's important to know that this camera, if there is the reflection of the lightning, that does affect also the distance detection. So it's important to know this information. Well, I think there is nothing more to add regarding this one. Please let me know what you think about this tutorial, and let me know if you use the camera and what else you would like to see using the Intel Realsense d435i camera. And this is all for this video. I want to remember also that I have an academy, so on pysource.com you will find the section Academy, where instead of these demos and short videos, I have full video courses also for beginners, where you will get detailed lessons and also more advanced source code about different computer vision topics. I hope you enjoyed this lesson. See you on the next one.